Hi guys, today we're back. We're on Unit 9, Lesson 6, and we're going to be doing our second day of solving trig equations. So remember, when we want to solve a trig equation, we want to isolate theta. Okay. We want to set it equal to 0, solve for the positive function value. That's going to be our reference angle. And then to get our solution, we adjust for the quadrant. So let's start off with an example similar to the one we did yesterday, to the ones we were working on yesterday. Solve each equation on the interval 0 less than or equal to theta less than or equal to 2 pi. Let's start right now, less than 2 pi. Sorry about that. And we're going to give the exact value of theta when possible. So 3 sine theta minus cosine squared theta equals 3. If you recall from yesterday, when we have these situations where one of our terms is squared and we have two different trig functions that we're solving for, we have to rewrite it in terms of the same function value and then use factoring to help us solve. So we're going to again go to the Pythagorean identity, sine squared plus cosine squared equals 1. 3 sine theta. Be very careful here. We're subtracting cosine squared is equal to 1 minus cosine squared, 1 minus sine squared theta. And that's equal to 3. We want to distribute this. 3 sine theta minus 1 plus sine squared theta. And we'll get everything to one side because we are dealing with a quadratic. So we want to make sure we have everything on one side and it's set equal to 0. Now let's just rearrange our terms and combine any like terms. Sine squared theta plus 3 sine theta. And I have -1 and -3. So this becomes -4 equals 0. And now this is basically a simple factoring. Remember, this is just like solving x squared plus 3x minus 4 is equal to 0. Okay, so think about that when you're working through these problems. If you were going to factor x squared plus 3x minus 4, you'd have no problem doing that. I put a sine theta, that's my variable. Two numbers that multiply to -4 and combine to give me +3. Plus 4 and -1. I want to set each factor equal to 0. So an angle whose sine is -4, obviously no solution. Sine theta minus 1 equals 0. Sine theta equals 1. Angle whose sine is 1, well, that comes from one of our quadrant angles. Remember, when we're solving for ones or negative ones, we think of our sine curve. What angle gives me a sine of 1? Well, that's going to be 90 degrees. And since it only happens one time, that's our only solution for this problem. Now let's see what happens when the angle is a multiple of pi. Now we saw a similar example yesterday. What do I mean by a multiple of pi? Well, there's a number out in front, multiple of theta. There's a number out in front of that theta. So yesterday when we solved a problem like this, we rewrote this using one of our properties. Okay. Today, this isn't going to help us. Because even if we went through and subtracted, right? Oops, -1/2. That doesn't do anything for us. Okay. So in either form, here or here, that doesn't help us because we have two different function values. We don't have a way to factor this. Yesterday, we were able to factor it and break it up into two separate factors and set each one equal to 0. But today, that's not going to work. So this is not going to be an appropriate method. So we're going to have to get a little bit creative here. And what we're going to do, since we're really solving for an angle, or in this case, a multiple of an angle, we're just going to let A equal 2 theta and rewrite this problem. And now instead of solving for 2 theta, we're just going to solve for A. So our reference angle is going to be the angle whose sine is 1/2. That's not so bad. What angle gives me a sine of 1/2? 30 degrees. Now here's where things are, well, not yet, not just yet. So we have our one solution and our function value is positive. So the solution here, our reference angle is 30 in quadrant 2, because that's where the sign is positive. 180 minus 30 is 150. So A is 30. A is 150. But remember, we're not solving for A. What are we solving for? A is really equal to 2 theta. We want to solve for theta. So theta is going to equal 30 divided by 2, which is 15 degrees. Or theta is going to be 75 degrees. So that's the first type, that's the first step in this type of problem. Now here's the tricky part. Let's go back and look at what we're actually dealing with. Sine of 2 theta. If you remember from the last unit, sine of 2 theta is going to compress our sine curve. So instead of our sine curve being like that, our sine curve is going to kind of go like this, right? This is sine of 2 theta. So basically, we just found two solutions, okay, but we may have more because of our interval. So what we have to talk about when we solve these types of equations with multiple, a multiple angle, we have to find what we call repeated solutions. And this is going to be based on the period of the curve. So if you think about it, a normal sine curve has a period of 2 pi. But since we're compressing our curve, we're going to take the period and divide it by the number out in front of our original. So we're going to have repeated solutions every 180 degrees. I know this sounds a little bit weird, but we basically found, right? Whatever we did, we found the two, we have to find the other two values for these solutions. So what we're going to do is we go back over to our original, right? I know one of my solutions is 15 degrees. I'm just going to take 15 degrees and add 180, and I'm going to get 195. And I would take 195 and add 180. But if you notice, what would that number be? 517, 375. That's outside of our interval. So the two solutions for our first batch of solutions here is 15 and 195. Now we just go and we work on this and find the repeated values for this set over here. So theta equals 75. 75 plus 180. 255. Ooh, that was really sloppy math. And just in your head, just think, if you add 180 to 255, you're going to be out of the range. So our solutions are 15, 195, 75, and 255. Now, don't get so stressed out, because normally when you're dealing with problems like this in a calculus course, they're going to just give you some type of situation that you only really have to find the first two. They're going to kind of make the intervals a little bit easier for you to work with. Let's try to perfect this method. So I have cosine of 2 theta equals negative radical 3 over 2. Again, I could rewrite it, and this one you can actually solve, but let's use the method that we just did. So we're going to replace 2 theta with a. So cosine a equals negative radical 3 over 2. And here's where some of the things we learned in our last unit come into play. Function value and the sine. So I want the angle whose cosine, and since I realize it's radical 3 over 2, and that comes from one of my special triangles, I'm going to solve for the positive function value, right? This is my reference angle. Angle whose cosine is radical 3 over 2, and that's going to be 30 degrees. If you don't have it memorized, just do it on your calculator. Second cos. Second cos. Radical 3 divided by 2. 30 degrees, okay? So you always have the calculator as a backup. Now I need to find my angles. So A is going to equal. I go back up. My function value is negative. So I know my solutions are going to be in quadrant 2 and quadrant 3. 180 minus 30 degrees, 180 plus 30 degrees. So just getting my solutions now, I have 180 minus 30. A is 150 degrees, or A is 210 degrees. But you have to, once again, remember, we're not solving for A. A is really 2 theta. So if 2 theta equals 150, then theta equals 75. If 2 theta equals 210, then theta equals 105. And the last step of this problem is just getting any repeated solutions that are within 0 and 360 degrees. So I go back up for my repeated solutions. I'm going to take the period of the cosine function divided by the multiple, whatever number's in front of theta, and my solutions are going to repeat every pi units, or since we're dealing with degrees right now, every 180 degrees. So I have theta equals 75, and 75 plus 180, we did that above, was 255. Again, if I add 180, I'm going to be outside of my range. Theta is 105, 105 plus 180, 295. It's kind of clear here, oh, 285, sorry. It's kind of easy to see that if you add 180, you're going to be outside. I'm going to write my answers up here. My solutions become 75, 105, 255, and 285. So this is just another way to approach, a trig equation. Let's look at the tan of 3 theta equals -1. Again, I have a multiplier, right? So we're going to let A equal 3 theta. Tan A equals -1. When I go to solve this, solve for the positive function value. So the angle whose tangent is 1, hopefully you remember this from last unit. If not, go ahead and use your calculator, is a 45-degree angle. Our function value is negative, so we need to adjust this. Where is the tangent negative? In quadrant 2 and in quadrant 4. 180 minus 45, 360 minus 45. So A equals 135. A equals 315. We are not solving for A, we're solving for theta. So theta is going to equal 135 divided by 3. What is 135 divided by 3? I can't remember. Oh, that's just going to be 45. Right? I don't know why I'm losing my mind right now. I'm just going to do it. Yes. 3 theta equals 315. So theta equals 315 divided by 3. So for this value, it's 105. So these are our 2 main solutions. Now we have to talk about our repeated solutions. Now the little trick here is the tangent function has a period of pi. Remember, it was different from, it repeated every pi units. So we're going to take pi and divide that by 3. So we're going to see repeated solutions every 60 degrees. So we have to go to each of our angles. 45 plus 60 is 105. Plus 60 is going to be 165. Plus 60, because I'm still within 360 degrees, 225. Plus 60 equals 285. That's a solution. Plus 60 equals 345. And I think that would be the last one, because if I add 60, I'm going to be outside of my interval. And if I was going to do 105 and just kind of think about what's going to happen here. If I do my repeated solutions, I'm just starting here this time, and I'm going to get all of the same answers. So I'm really technically done. So my solution set for this problem is 45, 105, 165, 225, 285, and 345. That one was a bit of a challenge. Okay. It's not, hopefully it's not hard to get the solutions anymore, this basic part. Okay. Your repeated solutions, I do agree, they're a little bit confusing and hard to work with. So, this year we want to focus on being just able to get our initial solutions. Now let's switch gears a little bit. And I have 4 cosine squared minus 3 equals 0. If I try to rewrite this with signs, that's not going to help me. I'm still just going to have one function value being squared. So think about how you would square. Whenever I'm not sure what to do when I approach a problem, I think about what I would do if there was just an x in the problem. So if this was 4x squared minus 3 equals 0, you would get everything to one side and square root it, right? You would not get everything. You would isolate the variable and square root it. So we're going to use that same approach over here. 4 cosine squared theta equals 3. Cosine squared theta equals 3 divided by 4. Take the square root of both sides. So the cosine of theta equals, remember when I take the square root when I'm solving an equation, plus or minus the square root of 3 over 4. And this is going to simplify plus or minus to radical 3 over 2. Now this next part, if you think about it, you're just doing, remember, our function value is something that comes off one of our special triangles. So we solve for our positive function value. Angle whose cosine is radical 3 over 2 is going to be a 30-degree angle. And what we have to remember here is our solution, remember, this is just a reference angle. Our solution is going to be the quadrants where the cosine is positive and the quadrants where the cosine is negative. So in this case, we're going to wind up getting 4 solutions. We want the angle of 30 degrees in all 4 quadrants. 30, 180 minus 30, 180 plus 30, 360 minus 30. So our solution set is going to be 30, 150, 210, and 330. Okay. So there you have it for today. We just tried to kind of give you a little sense of some different types of trig equations that we're going to be responsible for solving in this course. Please do your homework and I'll see you tomorrow.